Okay guys, so in this video we're going to be talking about combining like terms. So first of all, we have to figure out what the heck are like terms. So the definition is right up there. Like terms are basically terms with the same variable and power, or they could be multiple variables as long as they're the same and the same power. For example, let's say we have example number one. These are actually considered like terms because in example number one, -6 is the coefficient, the number in the front. 7 is the coefficient, the number in the front, but they both share k, the variable k. Therefore, they are like terms. So -6k plus 7k will give you a total of 1k. Again, this is just like the integer operations problems. The only difference is that we actually have a variable at the end. So -6k, I keep saying 7 for some reason. -6k plus 7k is equal to 1k. Same exact story in the other example, example number 2. It's -6, +7. The only difference is that it goes from k to k squared, so the answer is going to be 1k squared. So that term that they both share will actually stick all the way to the end of the problem. In this case, example number 3, they don't share a term, but that doesn't mean that they're like, they don't share a variable, but it doesn't mean that they're not like terms. So -6 plus 7 are actually considered like terms because neither of them have a variable, so they can be combined. They can be added or subtracted. In this case, the answer is just +1. No k's this time. Okay. Let's do some more examples with some different variables in this case. So let's do example number 4, example number 5, and example number 6. So in example number 4, we have 3m plus 5n plus m. So like terms, we're looking for the ones that they share. Notice that in example number 4, 3m and plus 1m, there's a 1 in the front that you don't really see. So we have 3 m's, and then one more m, we have a total of 4 m's. Don't feel sad if the 5n doesn't have a like term. It just doesn't. It just goes along for the ride. So the final answer will be 4m plus 5n. That's it. The only ones we can combine are the m's. Sample number 5, same idea. So we look for like terms. In this case, the like terms are the x squares. Notice that there's an x squared there and an x squared there. We could actually combine the 6 and the 4. We could actually combine the 5y and the other y, or the 1y at the very end, because those two are like terms. So again, integer operations, 6 plus 4, we get 10, except that they actually have x squares behind them, so it won't be 10, it'll be 10x squared. Don't forget the x squared at the end. Same idea with the 5y and the one more y, so we get 6y in total, so this will be plus 6y. That's it. So we're doing simplification by combining like terms. So this is your final answer. Don't feel like you have to combine stuff at the end. If they're not like terms, they're not like terms. Can't do anything about that. Example number 6. So we have 5x. Those two have x's. This is another x right here. That can be combined with the 5x. And then, this is 7x to the power of 3. That is 6x to the power of 2. Different powers, so they're totally different. They're not like terms. Don't try to combine these two guys. So the only thing we could do is combine the 5 and the other x, which is 6x in total. The other two guys go along for the ride. So it's just going to be 6x plus 6x squared plus 7x to the power of 3. That's all we could do. So done. Down to the last couple. So let's do a few more examples. Example number 7 and example number 8. So for example number 7, we have to combine these terms. Again, for them to be like terms, they have to have the same variable or variables and the same power. So if we do example number 7, we have a that can be combined with 3a. Those two have the same exact variable. And that's it. So don't be confused because these guys have a's and b's. Like this is 2ab and this is b. Totally different things. So they have to have the exact same variable with the exact same power, in this case a to the power of 1. So 3a plus one more a, we get 4a in total. So those two go together, and then the other guys just rewrite them over. They just go along for the ride, plus 2ab plus b. Done. Nothing else we can do if they're not like terms. That being said, example number 8, same idea. So 5w to the power of 3 can be combined with -3w to the power of 3 because they both have w to the power of 3 attached to them. But look, this is y to the power of 2, this is y. They're different. This has power of 1, this has power of 2, so we can't combine them. So all we can do is just 5 minus 3 is 2, so we get 2w to the power of 3 Those two are combined. The other guys just drop them down. They go along for the ride, so it's plus 5y and then plus 2y squared. So final answer, box it, and then moving along to the very last one. So the very last example, example number 9, we have this situation. So 5ab minus 7a plus 8b minus 10ab plus 10a squared. So it looks pretty crazy, but just stop and think about which ones are actually like terms. 5ab, we're looking for ab's here. So the only other ab that I see is that one right there with the negative 10. So those two can be combined. Let's see, 7a, do I see any other a's? I see that one, but that one's not a, that one's a squared, totally different. I have ab, no other b's. So we're done. So the only things we can combine is the 5ab and the negative 10ab. So if we subtract these two and keep the sign of the bigger number, we get total of negative 5ab. So the answer becomes negative because we subtracted and we kept the sign of the bigger number. And then we drop everything else down. So negative 7a plus 8b plus a squared. Done. Hopefully this helped.